So this second lesson is on intercepts. We've covered this previously. You guys did really great on it. So intercepts are those critical points where an object crosses either the x-axis or the y-axis. So x-intercepts are the points where an object crosses the x-axis. Now, on the other hand, y-intercepts are the points where an object crosses the y-axis. Now, algebraically, this is when y equals 0. So make sure you write this down. This is when y equals 0. X-intercepts occur at y equals 0, or on the x-axis. And actually, I'm going to type that down. Or on the x-axis. So, let me make that a little bit wider there. And y-intercepts occur at where x equals 0, or on the y-axis. Right? So, to find x-intercepts, circle the points where the object crosses the x-axis. So we're going to go to the graph, the curve below, and I'm going to highlight those points. And the way we are actually going to circle them, there's one and there's one. And the way we denote them is it's a throwback to when we did the unit on interval notation, or set notation actually, is we're talking about x values, right? So it's going to be, this is a point, these are points, x, y. Remember, y equals 0, so these points for the x-intercept, these points, I'm going to make a note, these are x-intercepts. Let's do it before. X-intercepts, right? And these points, they map onto, that's what the arrow means if you can't remember. They map onto, one of the points is 1, 0. And the other point is 3, 0. Now my y-intercept, there's only one on this curve. There's only one place where one point on this curve where it crosses the y-axis, and it's at 0, -3. And I'm going to just circle that with a blue marker. It's right down here. 0, -3. Easy stuff graphically. But algebraically, we're doing something a little bit different. What we're doing is we're saying that y equals 0 for x-intercepts and x equals 0 for y-intercepts. So we're just replacing things here, okay? So I'm going to go ahead and type this in. So first I'm solving for my x-intercept on this side. So I'm replacing the y. So 2x minus 3, parentheses, 0 for the y equals 6. I get 2x equals 6, and I divide by 2 on both sides, and I get x equals 3. So my x-intercept here is x, y, maps onto 3, 0. We make sure we use coordinate notation for this. Now my y-intercept, I have 2x minus 3y equals 6, and here x equals 0. So I'm replacing the x, 2 parentheses 0 minus 3y's equals 6, or -3y equals 6, or y equals -2. Now when we write our y-intercept, you make sure you write it in coordinate notation. Okay, we have x, y, and we get 0, -2. Flip the page. Over here, we have y equals 3x minus 4. we're looking for the x-intercept. That means y equals 0. So I'm going to solve for x. I get 0 equals 3x minus 4. I move the number term to the opposite side. I get 4 equals 3x's, and I get 4/3 equals x, excuse me. X-intercept form would be x comma y, or 4/3 comma 0. Okay. For my y-intercept, you have, let me write y equals 3x minus 4, and here x equals 0. So I'm replacing x, and I get y equals 3 times 0 minus 4, or y equals -4. And when I'm writing this out, I get the y-intercept is x comma y, mapping onto 0. Make sure you include in parentheses 0 comma -4. Next one, we have x plus y, caps x plus y equals 9. And we know we're looking for x-intercept on this side, so y equals 0. Sorry, I made a mistake there. It's a 9. And what we end up with is x equals 9. Or we end up with the coordinates 9 comma 0. Similarly, on the other side, x equals 0, so we end up with y-intercept that is 0 comma 9. So that's the algebraic way. On the next page, we're going to graph equations using these intercepts, and it's relatively easy. You plot the 2 points, and then you make a line. So for -2, 0, I'll go left 2, make a point right here, left 2, make a point here, and then down 4. Over here, I go right 3, and then up 4. Okay? And what I need to go back and do is just connect the 2 dots. Right? Oh, my bad. There you go. Connect those 2 dots to make the line. Okay? So there's one line, and here is the other. My bad. Here we go, all done. Now, what about finding equations? Well, there's a lot of things that can happen here. But this isn't as bad as it seems, so it's in slope-intercept form. If an equation is in slope-intercept form, I can automatically figure things out. So, in order to use the slope and the y-intercept to graph a line, first label the equation, put the slope in, and rise over run form, and then plot the y-intercept. And we're going to use that slope to graph the line, and then we can go back and answer these other things. So, rise over run, I have 2 divided by 1. Okay, so that means I go up 2 and right 1 when I'm graphing. Y-intercept is at -4. So here's my first point at 0 comma -4. Here's my y-intercept. It's my b. So at 0, -4, this line crosses the y-axis. So b and y-intercept are always connected. Now I'm going to graph using these 2 things and then find the x-intercept. So my next point is going to be up to right 1, it's right here, up to right 1, up to right 1, and I keep going till I go off the map, and then I just connect my dots. Here's my line. So this x-intercept is at 2 comma 0. It's at 2 comma 0. So I'm going to type that in. 2 comma 0. Make sure I use my parentheses. For the next one, it's already in rise over run form. So I'm just going to write that out. Negative 2 over 3. So I go down to right 3. And my y-intercept is negative 2. So I'm going to have 0, 0, comma, negative 2. And then go down to right 3. So starting down here at 0, negative 2. I go down to right 3. And here's my next point. If I wanted to go the opposite way, I go up to left 3 and make another point, right? And then I just create my line going through those points, and I find that my x-intercept is, I'm going to use blue this time, my x-intercept is right here at negative 3 comma 0. I have an x-intercept of parentheses negative 3 comma 0. Okay, flip the page. And so for the next two, what we're going to do is put them in slope-intercept form, and then you should be able to find the slope, the y-intercept, the x-intercept, and the y-intercept. So first, let's just put it in slope-intercept form. So we're going to move the x term. So we're going to have 3x plus 4y equals 12. That means I'm going to move the x term away from the y term. So I move 3x by saying negative 3x on both sides of this equal sign. And then 3x's go away, and I'm left with 4y equals 12 minus 3x. Okay? Divide both sides by 4, and I get y equals 3 minus 3 over 4, or 3x over 4. Okay? So when I write this out, I have a slope of negative 3 over 4. My b is 3. My x-intercept, I'll get it from the graph. My y-intercept is 0, comma 3. In fact, I'm going to type that out because that looks sloppy. Right? So 0, comma 3. And when I graph this, I'm going to go down and graph 0, comma 3 right here. And then I go down 3, right 4, and make a point. And my y-intercept, my x-intercept is at 4, comma 0. I can make my line at this point. And it looks something like that. Okay? So for the next one, you do that one on your own. You should be able to graph it. What you'll find is that your x-intercept is 2, comma 0. Y-intercept is going to be 0, 0, comma negative 3. B is going to be negative 3. Your slope is going to be, let me write that out here. Your slope is going to be 3 over 2. So when you graph it, it should look something similar to what I'm about to do. There we go. Have to bring it down a little bit. Here. Let me full Z. Do that over. And you're right here. There we go. That looks better. There's my graph. Okay? Now the last part we want to cover is the part about zeros. So zeros are just those x values in the x-intercepts. And they are the order pairs, the locations and the points where y equals 0. Sorry, x-intercepts, or the order pairs. Whereas on a graph, this is where an object crosses over the x-axis, and we said that repeatedly. And we always know at this point, y equals 0. So the 0 is the x value in this order pair. So I'm just going to go through and highlight these places where y equals 0, and there's an x value that pairs to it. So here, the first one is -3, 0. I have an x value here, here, and here. I do not have one in the third graph. I do have one here, and then for the last one, I have one here, and that's it. So I'm going to go back and write these zeros. So we write x equals -3. In fact, we write x bar, so curly bracket, x bar, x equals, curly bracket, -3. Next one, we have x bar, x bar, x equals, curly bracket, -2, 0, and 2.5. You have 3 distinct zeros. On the next one, if you notice, this object does not cross the x-axis. So we have x bar, x equals, undefined. Or you could write, or does not equal real numbers. Does not belong to the set of real numbers. Next one, x bar, x equals, curly bracket, 7. Last one, x bar, x equals, curly bracket, 5. And that's pretty much it. So the next section, you can do this on your own. You should be able to. It's pretty much repetitive what we just did. And your homework is here. So have a good day. I hope that helps. Catch you guys later.